Hmm. Well, this is interesting. Only in theory, 2 more minutes left and I'm close. Thank you. All right, I'm gonna give people a couple minutes to get here and I have to use the restroom anyway, so I'll be back. So much. If I knew that they're going to be here when I'm here. Gosh. Right. I don't know. There's been like 10 minutes and we're all just getting here and it was. I don't understand why we don't. That's the reason. Like you, that realistically is not my time, so like it's not. No, no. Oh, when. Something happened, like I really didn't want to. I would put some. No. Plus, really. Practice. That's.
For the short essay things, I type them.
That's fine. I mean, you did some staples and everything. Okay, you just send them to me. Yeah.
Yeah.
Do you have your exams? You can come on and bring them on up to the front.
I'm challenging myself to do this without calling out your names. I think I got it now, so. All righty. All right, so today, we're going to start talking about stats. I know some people freak out when we do this, but don't worry, we're gonna go slow. You're gonna have an assignment so you can practice thinking about it. And then either next week or the following, just depending on how long my lecture takes next week, we'll actually go to the computer lab and play with SPSS, and then you'll see like how quick it does, but it takes us forever to do by hand, which is cool. Just a reminder that by next week, you should schedule your meeting with me, even if you can't meet before next Thursday, schedule with me. If we have some time at the end of class today, I'm glad to meet with people just like after class. So whatever works for y'all. Just keeping everybody on track with our syllabus here. So today we're covering raw scores. And then we'll look at data interpretation next week. And then we get to actually dive into the assessments themselves. The reason I cover all this stuff so early in the semester is twofold. One is it allows you to sort of understand how these things are created that we're going to learn about. And the second, maybe more important one for this particular course is you're going to use this knowledge for your group project. So I want to get that out early in the semester. Speaking of which, hopefully people saw that I posted the groups. Basically, most of you had put yourself in groups already. And so I tried to give you like concepts you could come up with your questionnaire for. So we're gonna talk at the end of today's lecture about how to start thinking about writing items. And then either, again, today in class or between now and when y'all turn in your IRB, just again, depending, this class really is just sort of like a play it by ear. Let's see how quickly we get through things. And if we need to slow down, we need to slow down. Then you have a assignment to prepare you to submit your IRB. So lots more interactivity coming up in terms of doing class assignments that you can work on with groups, and also in a couple weeks starting to actually give each other assessments, which is really fun. So if anyone has suddenly decided they hate their group members, that I unintentionally have grouped you with someone who's your mortal enemy, just let me know and I can like very quietly switch people around. No one needs to make drama about it. It's good. Alrighty. And then, if you haven't gotten a chance, you can walk up and turn in your exam, or you can do it at the break, whatever is easiest for you. Alrighty. So the chapter numbers are really weird on these PowerPoints, so I apologize if they don't match up. But we're going to start talking about basic statistics and the ideas behind them, how you actually do them. And you're going to, like I said, practice these in class as well. So here's a question. Normally when I start talking about statistics, people either get scared or roll their eyes. Why do we actually need statistics in psychology or in life? Yes, right. Having to file your taxes, you need all that lovely stuff, right? I remember where I went to grad school, they had a city tax, and you had to file, but you literally took what you made and you multiplied it by something, and they always took out the correct amount, but you had to file. So you're using those ideas. What are the reasons we need statistics?
Because it's like a general idea about a certain population.
Exactly, yeah. So it allows us to like generalize or talk about larger populations, not just one person at a time. The numbers basically allow us to look at these larger groups. Yeah. Any other ideas?
In general,
Oh, sorry, we'll go here and here, yeah.
I was gonna say generally, like, this helps us figure out what the raw data actually is.
Exactly, helps us to give meaning to the numbers when we're staring at them. You were gonna say, maybe I should have just had you go at the same time. So yeah, I mean. So let me tell you a story. So I was one of those like smart kids in high school. Probably none of this will surprise you that I was a big nerd, right? And I got to like calculus and all that good stuff. And I could do it, but I hated it. I was not a fan of math, which drove my engineer father crazy, right? And then I got to college and I took statistics. And I was like, oh, this is why we do math, right? Which sounds so silly, but like, it just made so much more sense to me. And now I've gone to like voluntarily week-long statistics trainings and I'm forever using them for my research. So, you know, it's something that I've really come to embrace. So your book outlines two major purposes. One is descriptions, and this is kind of going along with what we were talking about in terms of describing larger samples, so we can get summaries of things or evaluate things or people relative to other things or people, right? And that's mostly what we're going to talk about tonight. And then the second thing we can do is make inferences based on these numbers. These are logical deductions that we can make, but we cannot observe them directly. And it can be about events, it can be about relationships between variables, relationships between people, things along those lines. And so this is why we do statistics, this is why we learn statistics. And it makes them very useful. Alrighty. So I just have something different in my notes, but we will forge on ahead. I actually, for some bizarre reason, have two versions of those notes, so I'm just gonna see if this matches the second one. I don't know, it's chaos, y'all. We're just gonna roll with it. Okay, we'll get there. So raw scores are what we get when we look at just numbers. So like when I go through and I grade these exams y'all did over the last week, then I will get a score, right, when I'm done. And as I'm going through and grading, I'll get like a raw score for your multiple choice section, a raw score for the short answers, a raw score for the short essays, right? So these can make it so that we can interpret things, but we have to know how. We have to have context, right? Like I have to know that this exam is out of 100 points, and that's how I grade it. So let's say Jeremiah scores a 47 on a test in one class, and Elise scores a 95 on a different test. Who did better? Well, the answer is we don't know yet, right? We need more context. How many items are on that test, right? Are there 47 items? Are there 50 items? And on Elisa's test, were there 100 or were there 950? Did she get a 10%, right? Instead of a 95%. And so we also need to know sort of the average of everyone who took the test. Is that good or not? I think I told you all last week about my chemistry professor who would make scores out of 50, but everyone would score around a 25 to 29, like that, and then he just made that a B. Right? So you're gonna have to know, are they curving? What's the average? Also, is the higher or a lower score a better score? It's traditionally when we think of tests, we think of a higher score being better, but is it golf? Right? Do you actually want a lower score? So without context, raw scores are actually meaningless. Raw scores tell us little, if anything, about how an individual did on a test, again, without that other context. You have to take those raw scores and do something to make meaning of them, to make them meaningful for you, and in my case, to make them meaningful for y'all when I pass back the exams, right? So I won't just have you have a score for each section, right? I'll add it up and I will put a letter grade on it, so you actually know what this means, what the context is. So how do you go about making raw scores meaningful? One of the ways you can do it is by norm group comparisons. These can be helpful to look at things like the relative position within the group of the person's score. And so the norm group could be everyone in the class. The norm group in theory could be everyone who's ever taken this class with me, right? When we get to the tests that we'll learn about, you'll start to give each other. Sometimes the norm group is 1,000 people of your age range, right? And how did they do, and how does your score compare to theirs? They allow us to compare the results among test takers who took the same test. So, you know, someone might get an A and someone might get an A-, right? And they allow us to compare test results on 2 or more different tests taken by the same individual. So this is something that I do, particularly when I look at like midterm grades, right? As I look at, we've had 2 exams before midterms, how did they do on exam 1 versus exam 2? Traditionally, people often do better on like the second exam they take for me, although now that they're take home, it may be different. It's sort of a brave new world. But just because they learn my testing style, right? And they learn to adapt to it, they learn to study for it. If it goes down, you know, did I not teach well? Or if they're the only person that went down, is something else going on in their life, right? Maybe I want to check in with them. And so one of the things that we will look at to kind of compare scores is something called a frequency distribution. And so this places scores on some sort of test or measure or assessment to reflect how frequently each variable was obtained, each score. So you want to define all possible scores and then determine how many people obtained each of those scores. And there is an example in your book on page 112 of what a frequency distribution looks like. It's just, you know, one person scored a 66, but 2 people scored a 38, that type of thing. But just staring at tables sometimes can be really difficult to understand things. So we're going to use a variable that hopefully you're all comfortable sharing to make our own. And so I'm going to have everybody go around and tell me your height. I'll start with me. So I am 64 inches. So I'm 5'4". If you can do inches, if not, tell me and I can convert it. I'm pretty good at converting it. All right. 5'6", so then you're 66.
71.
All right. 67. Was that 61? 4. Okay. I thought you said 61 and I was like, all right. 61. All right. 67. 5'3", so 63. Not surprisingly, we have a lot around 64 because that's the average height for a woman in America. What is that? 71?
Or 74.
74. Oh, okay. 63. Alrighty. I love the 0.5, y'all. It gives me life. Okay, so now what we can do is we can look at these numbers and I'm gonna kind of like run back, well. I feel bad, I'm gonna erase this pretty flower because it's gonna be a lot easier to do here. And so what we're gonna do is list each height and then list how many times we have that height. And so we'll start with our 61.5. Okay, we have one person at that height. I'm gonna cross them out as we go, so I make sure I get them all. And then we have a 63 and a 63.5. Okay, and then let's see, we have 1, 2, 3 people who are 64 inches. Again, I'm gonna cross them out as I go. No 65s, but again, looks like 1, 2, 3 people who have a 66, and actually, technically, if I'm doing a full frequency, I should have 65, 0, and then 66, so pretend I put in 62, 0 here, there we go. So 66 is also 3. And then 67, we got one person. 69, we have one person. 2 for 66. Oh, there were, good catch. Nice. This chalk is just inspired. And then we have 171, and again, what I should do is go 70, 0, 68, 0, 71, 1, and then 72, 0, 73, 0, and then 174. Okay, so we just made a frequency distribution for our height. So again, not that hard, you just sort of count up how many you have of each height, and voila. Again, we sort of tend to congregate around the 64, 66, but we have a fairly decent spread in terms of adult height, right? And so we can also use that information to make a graph. And there are 2 different types of graphs we can make from that information. One is a histogram, which is a fancy word for a bar graph. And then one is what's called a frequency polygon, which is where you kind of just draw the points and then make it one big blob. And so we'll do the histogram first, or yeah. And then I'll kind of show you how you would turn that into a polygon. So do this, and we're gonna start at 61.5. Gonna write out all our heights here to start. Make little lines just so I have a marker. Okay. And we need our 63.5 here too. Okay. So now what we do is we just say, okay, that's gonna be if we have one person who has that, that's gonna be if we have 2 people who have that height, that's gonna be if we have 3 people who have that height. So our x-axis, or the axis along the bottom, is height in inches. And then our y-axis, or the vertical axis, is our number of people. Okay. So then we just sort of depict what we have here. All right, so we have one person who has a 61.5, no one at 62, but one person at 63, one at 63.5, and then 3 at 64. Nobody at 65, but 3 at 66. If I remember correctly, we had 2 at 67, yep. And nobody at 68, 1 at 69. Nobody at 70, 1 at 71. And then 1 at 74. So voila, we made a histogram. Da, 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 da. It's not that exciting, but it does allow us to visualize this a little better, right? So like just looking at 2 columns of numbers, some people's eyes start blurring, right? But once you look at it sort of graphically, it's a lot easier to wrap your mind around it. So if we were doing the frequency polygon version of this, we would just sort of connect everything here. And it would become more of a blob, right? And then this line would go down here, and then all the way down and back up. And then down and back up. And then down and back up. Okay, so then we have more like sort of space under the line, but it gives us the same information. I like histograms just because I think they're a little cleaner, but some people prefer this method. You can also come up with what are called class intervals to make this cleaner. So I'm not going to redo it, but let's say we did want to make it cleaner. Then we could be like, okay, let's make up to here 1 class interval. So there's 1, 2, 3, 6 people here. And then we'll make this our next class interval. There's 5 people who fall in there. And this is our last class interval. And there were 3 people who fell there. And so then I'd be making one with bigger bars, but I would have a lot fewer numbers, right? So it looks a lot cleaner. And actually, real quick, I can make that right here. All right, so make this up to 6 now. And then we have our, I don't know, short, medium, and tall people, sort of arbitrary, right? And so then it would just be, if we have 6 people here, we have 5 people for this one, and then we only had 3 people here. And that one's kind of going behind the screen, but you can kind of get perspective on it. So again, this is the way, especially if you have something that isn't as range restricted as height, right? Like let's say we did scores on a test out of 100 and I gave it to 500 people, right? It's entirely possible I could have a full range of scores from 0 to 100, right? We do not want to be graphing out 100 of these things, right? So often what we would do then is sort of do the groupings by 10 points, or we might even do, depending on how many people failed, we might even say anything that's in that failing range below 60 all gets grouped together. And so again, this allows you to take a lot of data and make it easier to understand pretty quickly. So these are those class intervals I was talking about, and you can do this by making them very fancy and precise. I just kind of like eyeballed it, but you can do this whole procedure where you would take, you know, in our case, our tallest person was 74 inches, and then we'd subtract our shortest person who was 61.5 inches. I cannot math in my head when I'm teaching, so I could do it on my own usually, but when people are watching me do it, I'm really bad at it. Although when I was pregnant, I got really annoyed because I actually lost my ability to do basic math in my head. I was like, I'm a woman in STEM and I can't even calculate a stick. I was really annoyed. Okay, so there's 12.5 point spread basically between our heights. And then we could determine how many class intervals do we want, right? So we could say, I want 3, right? which is sort of what I ended up doing. And so then I'll get our proper decimal here. And that's gonna give us about a spread of 4.17 inches. That's our spread. And that's essentially what I did in my head, right? Just because I kind of eyeballed it and was like, I feel like this is a gut feeling that we're gonna have about 3 groupings here. But this is the way that you could do it precisely. And then here's an example from your book where they took the, again, big long list of numbers here, and they put them into class intervals. And so then you can really break down those frequencies and get something a little more meaningful out of that data. And so again, this kind of gives you another example of where we could do the same thing we just did, but with like points on a quiz or a test, right? And we would just see how many people got a 15, how many people got a 16, right? And then we could create class intervals and have these smaller amounts of point spreads. Alrighty, so. Is this the same data? It is. I'm probably meant to put that other one after this. Well, we saw what it looked like. We're good. And you all are going to practice it with a different data set later. So we will skip on ahead here. Actually, let's have you all just practice making a histogram. So go ahead and take these numbers, just the class intervals with the frequency, and draw yourself a histogram if you've got some paper. If not, you can create it on your computer. And just take a couple minutes to do that and see what that would look like. And then I will erase and do the same thing on the board. All right, so I'll try to put my head in front of mine for those of you who are still doing it, so I don't give it away. But as we just established, I'm only 64 inches, so there's only so much me and my hair can do. So. Gonna switch these slides. What I find is sometimes when I upload to Google Slides, stuff gets messed up, and that may be what happened here. And you know what? I'll leave that where it is. Okay. A couple people might still be working, so I'll give it like another minute. And then you can start to check against my answer on the board. Now, you notice that just because of how I'm drawing on the board, my columns don't touch in my histogram, but often they're depicted touching, so. And for those of you who have either the paper copy of your book or are following along, they have an example with different numbers of a histogram and a frequency polygon in figure 6.1 and 6.2, which in the text copy is on page 114. The other thing you can do if you are on your computer is that you can actually put numbers like this into Excel, and then you can tell it to create a histogram for you. Which is all. I remember it's much better now. There's actually a lovely point and click program for it. But early in my grad school career, if you did a certain type of analysis and wanted a graph for it, there was a program that ran in Microsoft Docs that you would do it. So you actually had to like tell it what to do. It was very clunky. All right, so this is what it should look like. So we got a lot of people and not as many growing, nobody in this range, and then just one person at the end. So again, this gives you a feel for what those are gonna look like. All right, you can also do something called an ogive curve. I honestly have like never made one of these for any of my data, so I'm just gonna tell you about them, that they exist. But if you want to see a picture of what one looks like, there's one on page 115, table or figure, sorry, 6.3. And there's a table right above it with the data. And basically what it does is it gives you information about the percentile rank. And so you would convert the frequencies here into percentages, and then you add it to the previous percentage. So it's like, instead of being how many people were at each score, it's like how many cumulative people got at least like got that score or lower, basically. And this helps to determine the percentage on any point in the distribution. And your book actually talks about percentiles more in chapter 5. But they introduced this here, so it's kind of weird to me to do that. So we're going to talk briefly about percentile ranks now. So you're not sort of like, wait, what is even a percentile rank? Maybe. Alrighty. So the percentile rank answers the question for you. What percent of the scores fall below this particular score? And they call that XI in math units. So there's 4 simple steps. So you determine how many cases fall below the score of interest. And then you determine how many cases are in that particular group. You divide step 1 by step 2. And you multiply the results by 100. And so the formula for this looks fancy, but it's really not, I promise. And it is BR for percentile rank. Sometimes they actually use symbols that make sense, right? Is B, how many cases fall below over N, the number of cases in that particular group, and then that times 100. Alrighty, so let's use this data here. And I'll actually go back real quick just so I have it on the screen. Alright. So let's say I wanted to look at people in this 25 to 29 range. So below that, there's 8 plus 3 people, so that's 11 people. And then how many people are in this particular group? 4, so that's our N. And we're multiplying by 100. And then we'll have a percentile range. So real quick. All right. So 11 divided by 4 is 2.75 times 100. Or how weird, hang on. Yeah, something's wonky about this one. I think I did something wrong. I wonder if our N is supposed to be our total N to that point. That would actually make more sense. Y'all, I'm just having a brain fart day, so thank you for hanging with me. Yeah, that would make a lot more sense. So if we divide 11 by 15, then we get 0.73. And so then if we multiply that by 100, then we get 73% of the people scored at that level or lower. That makes a lot more sense. Thank you for bearing with my brain. So one of the things you'll often hear told about, not only in stats books, but just in like social psych books in general, is the idea of the normal curve. And so this idea is that if you look at stuff in nature and sort of the natural laws in the universe, the laws of probability, if you take most distributions and you divide them in half, you'll have the same number of scores on the right side as on the left side. And this will come into play a lot later on when we talk about converting things to z-scores, which are used a lot in assessment. And so then we have rule number 2 from your book, which is God does not play dice with the universe, which is a quote from Einstein. And what can happen is you can actually get skewed curves. So again, for those of you following along, this should be page 117, and it gives you an example of what a skewed distribution can look like. And so if you kind of see down here, if you don't have your book in front of you, the normal curve is the nice bell looking one, but it can be skewed in either direction where there's like a lot of people like who have higher scores and higher scores, right? And so they can be skewed in either direction. So you can have a positive skew. With a positive skew, the majority of the scores fall near the low end. So positive skew, majority of the scores fall near the low end. Negative skew, the majority of scores fall near the upper end. And unlike the bell curve, the normal curve, if we did take and divide it down the middle, we would not have the same amount of people on both sides. And sometimes we get data like that, particularly with psychological concepts. They're not as pretty, they're not as randomly distributed like in nature. And sometimes it's a problem of our measures, right? So something like, having a ceiling effect on something might make it more negatively skewed. So we've been talking about just looking at the data overall. But what we can do is start to map a little and look at what we call measures of central tendency. And these tell you about the center of the series of scores. It helps to start to put more meaning on the scores. And there are 3 different ones that we were talking about: mean, median, and mode. And if it is on a normal curve, the mean, the median, and the mode will be the same number, actually. But as soon as your data starts skewing, they will start coming apart. And again, on page 119, you'll see there's an example of this. So the median is the middle score. And interestingly, this is one that, I don't know if it's economists love to use it or the media just loves to use it when they talk about the economy, but they'll often talk about like the median income for the US is blah, 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 right? So the median, is just the middle score. So let's say we had 501 people in a data set. The person directly in the middle, you would have 250 people above them, 250 below them. That person, that score in the middle, boom. That is the median. If you have an even number of scores, so let's take something like a test out of 100 points, right? Then what you would do is average the 2 middle scores, and that would be your median. So the median, in my opinion, doesn't give you that much information about the rest of the data, right? It's just like, here's the score that happens to fall in the middle of everything else. And again, if your data is skewed, that won't necessarily be that close to the actual average or center. The mode is just your most frequent score. So in this distribution that we drew, your mode is your 15 to 19, because there are 8 people who have them. And then the mean is probably what you're most familiar with. The mean is a fancy word for average. And you take all the scores, add them up, and then you divide them by the number of scores that you have. It's the arithmetic average. So, okay, we've got this. Why do we need to do that? Well, what means and other measures of central tendency do is they help you summarize the information. And we have a huge data set sometimes. So I have one data set that I collected with a fellow psychologist at VU that we have 1,200 people in the data set, right? If I was trying to like visualize what that data looks like and what's the middle of that data and what's the average, that'd be really hard, right? But with a formula and with a statistical program, it becomes much easier. And this is the formula for the mean, which is sometimes represented by an X with a bar over it. And again, it looks intimidating, but it's not. This sigma here that just looks like a fancy E just means you sum. So you sum all the X's, and in this case, the X are all the different scores. And so you would add up all the different scores, all the heights in our class, all the numbers in our frequency distribution, right? And then you would look at the N, the number of people, right? And so then you would divide by the N, and what you get is the mean. But those only tell you about the middle, right? They don't tell you anything about stuff beyond that. And that's where measures of variability come into play and can be really helpful. And so these tell you even more about a series of scores. So there are 3 types. The range is the easiest one. Just literally the highest score to the lowest score +1 or minus the lowest score +1. You can do this calculation, or you can just literally depict the range. So a lot of times when you see range reported in like a scientific article, they'll just be like, it ranged from 5 to 25, right? They won't have done this calculation. There's the interquartile range and the standard deviation, each one of which is going to get their own slide here. So the interquartile range is about the middle 50% of scores. It's around the median. And again, your book does a good job illustrating this. It's on page 120, figure 6.7. It's basically the people right above and below the median. And so you can, where N is your number of scores, you can use that to calculate your interquartile range. Again, this is something stats books love to point out and have you learn to do. I don't think I've ever used it, and I've been doing stats since 2002, right? So don't worry about it. So next we're going to talk about the standard deviation, and this is used very frequently. It's rare to see a publication that doesn't report means and standard deviations in some way, even if it's just the mean and standard deviation of the age of their sample, right? But that's pretty common. And what we're looking at here again is variability, and we're looking specifically at measuring it. Basically, what the standard deviation does is it helps you find the average deviation or variability from the mean. So like, here's my mean. On average, how far out are all the scores on either side? So if you have a really tight normal curve, right, your standard deviation might be pretty small. Everybody kind of falls into a pretty small area. But if you have sort of very varied scores, your standard deviation might be huge. And so here's the formula. And so what you're doing is you are taking the square root of the sum of your score minus the mean squared over the number of scores that you have. typically the number of people in your sample. So again, X here is the score. In this case, rather than using X bar, they're using M. That's your mean. And then N is always the number of scores that we're looking at. There we go. All right, and so this is how you actually calculate it. So let's say this is our list of scores that everybody got. You would just add those all up and you would get 80. Now, in order to get the mean, then what you would have to do is, get on here, yeah, is take your number of score or your total from all the scores, and then the number of people, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And so our mean here is pretty easy, right? Our mean here is 8. And I had it already calculated, but just wanted to show you real quick what that looks like. And the more I'm staring at this, the more I'm realizing I know what happened, which is the last time I taught this class at this time of year, I had COVID. So I was teaching from home, so I didn't have a board to write on. So I just filled it in on the slides. So we've got everything worked out. We don't have to do it by hand right now. So then you would just take each number and subtract it to subtract the mean from it. So 12 minus 8 is 4. 11 minus 8 is 3. Sometimes you're going to get negative numbers. It's not going to matter because you're going to square it, right? So down here I didn't even bother with the signs. And then the next part you're going to do is take that, the X minus M, and you're going to square it. And so 4 squared is 16, 3 squared is 9, etc., etc. And then what you do is you add up all the X minus M squareds. And so that gives you 88. And so what we've done on this big chart is done essentially this part. We've gotten the top of our fraction there. And then we know that our number of people, because we already looked at it, is 10, right? And so then we're gonna take that number we just got, our sum of the X minus M squareds was 88. We're gonna divide it by 10. Okay, and so then we're gonna have 8.8. Looks like the square root got kind of weirdly juxtaposed there, but it's supposed to be around the 8.8. And the square root of 8.8 is 2.96. So that means for this sample we looked at that has a mean of 8, the standard deviation is 2.96. So as you can see, a lot of times the standard deviation is a good chunk of the mean, right? That it's going to vary quite a bit on either side of the mean. There's a technique that I use. I was actually describing it to one of my research students today. It's called, and it's a type of assessment that's used pretty frequently in my field for just like a quick free post. It's called a visual analog scale, VAS. And it's just a bar. And these are really easy to do on online surveys because it just does it for you. And you say from 0 to 100, how are you feeling right now about your appearance? Where 100 is awesome and 0 is bleh, right? It's a little more scientific, but you get the idea. And so then they just sort of like drag the little dot to where they're feeling. Maybe this person's feeling pretty good. And so then you get an average of where that dot ends up. This one's probably about 65 or something like that, right? And so what you find is the standard deviation for these are often huge, right? They're in like the 40s or something like that, because people are going to vary quite a bit and you've got 100 different points, right, to vary on. And so having a giant standard deviation isn't bad or good. Just like having a small one isn't bad or good. It's just, again, describing your sample. Your mean tells you what's the average, and the standard deviation gives you an indication of how much your data varies around that average. All right. So one of the important things that we want to talk about here is to remember that we are doing this on people, right? And that sounds so silly, right? But it's true. And sometimes when we're just staring at numbers, we forget that, right? We forget that these represent people, and these represent people's individual experiences, either taking a test or giving an individual indication of how they're feeling about their appearance right now, or their emotions, right, or their IQ. So this helps us to understand, again, where a person's falling relative to their peer group, but that's how a person feels. And that's really important. And that their interpretation of that score can be really meaningful, right? You can tell 3 different people your IQ is 100, right? And someone will be cool, awesome, great, that's average, I'm good. And someone will be, that's higher than I thought, I'll go with it. And someone will be devastated because they always thought of themselves as really smart, right? And so that's something else to kind of keep in mind as we do talk about assessment, is not only are we sometimes even measuring how people feel, but like people have feelings about their scores. Like I have given exams back to people, they get a C- and they're like, woo! I give exams back to my high achieving students who had a bad day and got a C-, and like I can tell they're trying not to cry, right? So it's like each person's going to interpret that a little different way. And when we're giving feedback to a person, when we're working with a person, we need to keep that in mind, but just also in general, we need to keep this in mind, that all these data points we're looking at are people, right? When I'm looking at 1,200 data points, each of those is a person. Each of those has a name, each of those has a family, right? Each of those is a person existing in the universe. And especially when we're looking at stats, it can be easy to forget that. So when we are sampling people, what we often are doing is getting what's called a sample. A population would be all the people for that particular thing. So let's say I wanted to study how college students feel about their appearance. If I were to do that, I would probably like put it on Sona, have students in our classes fill it out, right? Go from there. So I would really be getting how students in Virginia Wesleyan psych classes feel about their appearance, right? So from a particular area, choosing a particular major. If I really wanted to do, how do all students care, college students care about their appearance or age, I don't know, 18 to 22, I would have to sample every single person attending college across the world, the US, Virginia, right? I'd have to decide what is my population I want to look at. The population, again, is typically we're not going to collect that. Typically it's impossible, improbable, expensive, things along those lines. But we always sort of keep the population in the back of our mind because the idea is hopefully the data we do collect on whatever sample of that population we use, we can generalize our findings to them. So the sample are the people in your study. So example, I'll take this study that I collected with my colleague at ODU. And so we wanted to look at both African-American and white students' body image. So again, I could go all the African-American and white students everywhere. Probably not gonna get them. All the African-American and white students at Virginia Wesleyan and ODU, probably also not gonna get there, right? so that would be my population, but my sample would be some of those people. And in a lot of cases in psychology, it's what we call a convenience sample. It's the people who sign up and actually take part in your study, right? And that's just reality of what you can do. And so let's think about the population versus samples. So let's say we wanted to look at voting habits of people who identify as Democrats. What would our population be? Yeah, everybody who identifies as a Democrat, right? Whether they're registered that way or not in the US. I think it's about half the population of the US. That's millions of people, right? But our sample might be Democrats in Virginia Beach who agree to take part in our study, right? If we looked at something like college students' attitudes for drinking alcohol, it kind of gave you the population for this already, right? It'd be all the college students ever. But our sample instead might be Virginia Wesleyan students, or I'm so glad. So when I was in grad school, your first 2 years, you were often funded by helping your advisor do research. And I had some pretty low-key studies, like having people come in to take surveys, or like sitting in doctor's offices waiting rooms to recruit people to take surveys. But as soon as I started teaching, which is how I made my money after that, one of my colleagues in my lab, my graduate advisor started collaborating with a new professor they got who studied alcohol and alcoholism. And so they would go out at 2 a.m. when the bars closed in Kent, and they stand outside the bars with pizza to entice the drunk people over and have them fill out questionnaires. That's a cool way to get data, but I would not want to be in that position myself. They were in a group, so they were safe, right? Including the professor who studied alcohol was a pretty burly guy, right? But the quality of data, as you can imagine, wasn't always that great either. Like Danielle was my colleague, and she showed me one time. It was like a series of questions, and someone had just like put a big circle around the whole page, right? Like, it's hard to get this data sometimes, right? And what they were interested in looking at was like, does binge drinking relate to binge eating? Which is a cool question, and actually it does. But yeah, so you can get really creative with how you collect data, right? And sometimes you have to. So for example, over the past 5 years, I've collected 2 very specific samples. The first was sexual minorities, so people who identify other than heterosexual. And then just this summer, I did gender minorities, which are people who identify outside the binary. So non-binary, genderqueer, trans individuals. If I tried to collect that on campus, I might get like, I don't know, 50 people who are willing to participate for the LGBTQ+ folks. And trans, you know, at least of the people I know who are openly out as trans, 10 or less, right? And so there are different data collection websites where you can pay people to take your surveys. I actually tried a new one this summer and really liked it. So it's called Connect. And you put your survey out there, people sign up to take it. And it was really interesting because when I was working with the company who runs the site data set, they're like, oh, if you want that population, we're gonna have to like have you do this more expensive way and like really go through all the data. And I don't know if you're going to get anything from our population, but they hadn't collected that demographic information. They hadn't collected whether someone identified that way. And I knew from the research I've been doing that somewhere between 5 and 8% of the population now identifies as other than binary gender. And I said, okay, how many people do you have in your sample? And they said 20,000. I said, well, I'm looking for a sample of 300, right? So even if we go the low end, 5%, I should be able to get them, right? Hopefully. And in fact, within 24 hours, I collected 300 people who identified that way. And I always find this data collection really rewarding because I'll always have a thing at the end where they can tell me if there's any problem with the survey or if they just have any comments. And people will write things like, thank you so much for doing, research on non-binary folks, like no one does this. So Yeah, you have to be creative sometimes. You have to go out and get the drunk people, or you have to, find other ways to collect your data. So the purpose of sampling people is to try to get a group of people in the study that allows the research to apply to the whole population you want to look at. So again, I haven't even had the chance to really look at that data. I collected it the week before classes started, and it's always really busy the first month or so. But my hope is that the people who participated in my study will be representative of the general American population who identify as a gender minority, right? The idea is if you're sampling well, there's actually no need to test everyone in the population. You just need that representative group from the population to study, and that's your sample. And, if we used our two examples from the previous slide, right? If we're looking at Virginia Beach Democrats, we want to generalize to Democrats. If we're looking at, college students' attitude to drinking alcohol, and we're looking at people in Kent, Ohio on the weekends, right? We're hoping that that generalizes to the population of interest, other college students who drink. So you want to be maximizing what's called external validity. And external validity is just a really fancy way of saying generalizability. We like to have fancy stats and terms. So one of the ways we can do this is to try to get what's called a representative sample. So when you do this, you're going to try and get a sample that has the same distribution of characteristics as the population of interest. So if I wanted to study Virginia Beach Democrats, right? I try to look at nationwide. What are the percentages of men, women, non-binary folks who identify as Democrats and hope to, or actually sometimes you actively recruit to get people who meet those criteria, the same percentage in your sample. Maybe I also want to look at race, right? African American, Latina, Latino, Latinx, right? Native American. Maybe I want to look at socioeconomic status or tax bracket, right? And then you would just actively recruit, and then I need, doing 1,000 people, 20% of people nationwide who identify as Democrats fall into this tax bracket. So I would just recruit until I got 200 people. And then I wouldn't recruit anymore from that tax bracket. And so if you've ever taken surveys online and they have you fill out demographics first, and then they're like, oh, sorry, we don't need any more people like you. That's what they're doing. What can happen is, even with the best of intentions, is what's called sampling error. And sampling error is the extent to which the sample is not representative. That something happened and you might end up with a biased sample. So most samples, even if you do all this really careful recruitment, are not 100% reflective of the population. They typically have different characteristics than the population sample itself. So if we look at Democrats in Virginia Beach is pretty white in a lot of areas, right? Not every area of Virginia Beach. So you have to make sure you kind of reached around Virginia Beach. And if I looked at Democrats where I went to grad school in Kent was like 90% white, right? So that's not going to be representative. And this is sampling error. And it can happen accidentally, or it can happen just something you're aware of because of where you are. And this can result in what's called a biased sample that might overrepresent some parts of the population, but underrepresent other parts. So again, you might have too many people who are Caucasian, not enough ethnic minorities, and therefore you have a very biased sample. So there are different approaches to sampling people beyond what we just talked about. So non-probability samples are just acknowledging that not everyone in the population has an equal probability of being in the sample. And this is the case with a lot of research. So for example, even my sample I got over the summer, you had to have access to a computer or your phone, access to high-speed internet. You had to know about this site and sign up for it, right? And so it's probably very different and much more tech savvy a sample than the general population, right? And it is impossible, unnecessary, or impractical a lot of times to try to make sure you're sampling everyone in the population or even that it's perfectly representative. So as I mentioned, the most common type of non-probability samples are what's called a convenience sample. It's just like whoever signs up, they're your sample. And so researchers use whoever's readily available. This is why a lot of research in psychology is published on college students, particularly first-year college students, because they're a captive audience in intro psych courses. And they're often required to take part in studies or they get extra credit for it. You can do this in other ways too. So maybe you put an ad in the paper or you run a banner ad on Facebook. Does Facebook still have banner ads? Side ads, maybe, I don't know. And you say, should we do research with stem cells? We just talked about this yesterday in my clinical neuropsych class. Stem cells have great potential for helping a lot of diseases, but because one of the places we get stem cells is aborted fetuses, they're very controversial and ethically. And so maybe in this ad, you just say, call this number for no, call this number for yes. Sounds good. Sounds like you'd get lots of people. All they have to do is call a number. Well, some problems with this approach. Well, one is they have to call. How is your generation about calling people? Do you guys call people or do you text? Text, yeah. I don't pick up the phone if it's not a number I know. Like, I remember during the 2016 election, actually telling a person, like, you can't call me. Stop calling me. I want to support your candidate, and whenever the phone rings and it's a number I don't recognize, I assume it's either spam or an emergency, basically, that like one of my loved ones is in the hospital, right? And if I have to pick up a phone and call someone, if I can find any other way to do it, I'm going to do it that way, right? I'm trying to set up an appointment with one of my doctors. We're emailing back and forth through the portal. I could have probably done it in 5 minutes if I called them. Did I call them? No. Right? Let's keep going back and forth through the portal, right? The other things is you might find that only certain people would respond to this type of ads. People are real go-getters, like, yeah, I want to help out science. Or people who care really strongly about the issue of stem cells one way or the other, right? So you might even have certain personality characteristics. You also have to have access to a phone, right? And for all of us, we're like, yeah, no problem. But we know phones are expensive. The plans are pricey. The phones themselves are like ridiculous now, right? I think like the new iPhone is like $1,200 and that's cheap compared to some other phones, right? Like, I think like the Samsung Galaxy Fold thing is like $2,000. I think that's more than I paid for my first computer, right? It's just, you know, so some people don't even have access to a phone. And we might also get more people who just are bored, right? Who want something to do. I'm sure if you did something like this during the pandemic, you'd probably get more people. One of the podcasts I love that I listen to about gymnastics, they haven't really been posting much in the past year. And I listened to an episode today and they said, you know, we started this during the pandemic. We have a lot more time on our hands. And they both work full-time jobs, right? Podcasting is not their job. And so I think it's the same way that like during the pandemic, people were like, sure, I'll call, sure, I'll take your survey, right? I don't have anything to do. Let's do something. Literally, I was like, what do I do with my 5-year-old during the pandemic? We got pipe cleaners and she had fun sticking them through a colander. And I was like, she's working on fine motor skills. This is great. We'll go with it, right? Like if we were all desperate for something to do. You can also do what's called quota sampling. And this is a type of convenience sampling where researchers try to ensure that certain kinds of participants are obtained in particular proportions. So again, similar to what I just described, to try to avoid sampling error. So if you're trying to look at men and women or Republicans versus Democrats, you would try to get half and half of either of those. You can also have what's called probability sampling. And this is a sample where the researcher knows the mathematical probability that any individual in the population is actually included in their sample. So basically, everyone in the population has an equal probability. You know, we say of being in the sample, but it's typically of being invited to be in the sample, right? We can't control who actually agrees to be in a study, nor should we. So when you're using this type of technique, then you have a much better grasp on estimating how much of your sampling and how much of your data is being affected by sampling error. And so you compute something called the margin of error. And this is just the degree to which the data obtained from the sample are expected to deviate from the population. And so, you know, we often see this, I mean, and this has been in political polls since at least the Kerry Bush race. We're just a very divided country for the past couple decades, right? Where you'll see one candidate has 52% of the vote poll-wise, one has 48, but then when you do the margin of error, it's like 3% in either direction, plus or minus 3%, right? So like, if Kerry went up 3% and Bush went down 3%, then they could switch, right? And so it's like almost like this poll isn't actually able to tell you anything. This is sometimes referred to as a statistical dead heat, because based on the stats, you are not able to tell who's actually in the lead. And so that difference there, that plus or minus 3 is your margin of error. And so really what that means is like John Kerry's true percentage of votes was anywhere from 45 to 51%. And Bush's true percentage of votes was anywhere from 49 to 55%, right? And so there's a good deal of overlap there. Fun fact about this particular election, this was in 2004. I had graduated college by then, I was in grad school, but my husband was a year behind me. And so he was still at school. He went home to vote. He was still registered where his parents lived. But a lot of folks in my college would change their voter registration to Little Gambier, Ohio. Gambier, Ohio, when it doesn't have the students there, only has 500 people. So they had 2 voting machines, and one of them broke. I think about 800 students registered to vote. So my husband's roommates were in line, because if you're in line when the polls closed, you can still vote, no matter how long it takes. They were the last people to vote. They voted at 2 in the morning. That district, because Kenyon and the area where I went to school is pretty liberal, but in a sort of not liberal part of Ohio, went largely to John Kerry. They became like a national news story, and actually the following year John Kerry came, my understanding is for free, and was the commencement speaker, sort of like a thank you, which was kind of cool. Yeah, it was not that school year, but the next year, just because of the logistics. And also my husband's graduation speaker was David Foster Wallace, which like his speech is actually really famous. It's called "This Is Water." Amazing. Best speech I've ever heard, much less best commencement speech. So yeah. Alrighty. Other things you can do. simple random sampling. This is a type of probability sampling. You get a random set of people from the whole population, and everyone has an equal chance of being sampled. You can do this a couple different ways. You can put everybody's name in a hat and pull them out. A lot of times now what we do is use a random number table, or there are websites that do this for us, like one is called random.org. If I was doing this in class, right? I again could like put all your names in a hat, you could pull it out. Everyone has an equal chance of being chosen. So they'll do this with like the names of everyone who lives in a certain place. Or I don't know if they still do it this way, the way they used to select people for the committee that decides on the Samuel Nelson Gray Teaching Award. It's actually a student committee that decides who wins that, which I think is really cool. Is they would just randomly select students for like the full student roster, which was really funny one year because she's since moved on to a different university, but I had a friend in political science who her husband actually decided to do a degree in environmental science here. And he was randomly selected to be on the committee, and he had to turn it down because his wife was nominated for the award. And he's like, I don't think I can be unbiased. Right. So people used to do this with the phone book, back when the phone book was more of a thing, right? Every once in a while we'll still get one. It just goes right in the recycling bin, right? And then you can have what's called stratified random sampling, where you divide the population in what are called strata. So maybe you do, 10 to 19, everyone ages 20 to 29, 30 to 39, 40 to 49, etc. And then you randomly select from the strata. So instead of selecting from the whole population, you say, here's a list of everyone who is in the 40 to 49 age range. We're going to randomly select from these folks. And then there's what's called cluster sampling. And this is because you generally don't have a list of everyone in the population, right? They're just floating around, and that's a good thing. You'll sample whole clusters of the population, then get random participants from that cluster. So for example, let's say we wanted to look at teachers in Virginia who teach at public schools. Well, rather than look at all the different public schools in Virginia, we could say we're going to take 15 school districts around the state, and we'll randomly sample teachers from within each school district. That way it's a little less time consuming, less costly, and it requires fewer resources. And this is, if you really want to do random sampling, this is the easiest and most practical method, like the true probability sampling. But like I said, the vast majority of people are just going to be doing convenience sampling. There are threats to our samples not being as representative as we want them to. We do want representative samples so that we don't have a biased sample that doesn't truly reflect the population. So one of these we've kind of hinted at already, and this is response bias. And this is that certain people are going to have more time or more interest in completing questionnaires, right? So I've had times in the past where I try to recruit for a study and I send an email to the whole student listserv, but still the vast majority of people who sign up are psych students because A, they're interested in it, B, y'all get extra credit, right? So much better. And this could be problems with online surveys, telephone surveys, people who don't have access to the technology, people who are unwilling, people who work odd hours. And so because of that, your final group might not be representative of the population. So then you want to look at selection bias. And this is when the sampling procedures themselves, how you select the people, are going to produce a biased sample. So there's something that happened during the selection of your sample that made it biased. So again, having people do internet surveys. This is biased towards people in urban areas who are upper, middle, or upper class. They can afford computers, they can afford internet access, right? And it seems to those of us who are lucky enough to be at a place like Virginia Wesleyan, like, what do you mean that's not everybody? But like even during the pandemic, We had students who are from rural areas who like couldn't get access, right? And so that makes it much more challenging to do your schoolwork. Particularly when you can't just like go to the library because it's closed because of the pandemic, right? Then there can be what's called misgeneralization. When you try to generalize the results from your study to a population and the sample's not representative of it. So maybe we sample kids in private schools and we ask them about eating disorders. And then we try to generalize that to students in public schools. We know again that people who go to private schools have to be from those middle and upper classes, that there might be different pressures on them versus kids who go to private schools. And so in general, we should not do that. We should not try to generalize from one population to another. Okay, it's like 7:27. I'll give y'all till 7:45 or after a break, just because that was a lot of stats. When we come back, what we're gonna do is a really brief lecture talking about how to write test items. And then we have a couple different activities I'm gonna have y'all do. So go ahead, take a break, get a breather. And I will see y'all in a little bit. Alrighty, I'm just gonna talk at you a teeny bit more, I promise. And then you're gonna get to do 2 different activities. So the next one is for your group project, and it's about writing test items. So these are the ways that y'all are gonna start thinking about the type of questions you want to be asking on the questionnaire you're completing with your group. So there are different item formats. There we go. That you can use. And we're going to go over each of these on a slide of their own. But item formats are essentially talking about how your participants, the people who will take your study, will be responding to the questionnaire that you create. So dichotomous is where the person will just answer 2 alternatives. It's typically like a yes, no, or a true, false. These are simple, easy to administer, and quick scoring. On the other hand, this can lead to low reliability. We talked about reliability and how important it is last week, right? And then it can force a simple answer, which can mean that person might actually have a more complex answer, right? Or let's say it's on a test, you could be encouraging memorization more than deep understanding of the material. And sometimes on tests, we just want you to memorize stuff, right? But other times we want something more rich. So we have dichotomous, and then we have polytomous, where each item has more than 2 alternatives. This can be like a multiple choice question. In here, there's a right or wrong answer, right? So this probably won't end up being your questionnaires because you're going to be more asking about how people think or feel. But I still just like to kind of inform you about every possible answer. Incorrect choices in this case are called distractors because they distract the test taker from the correct answer. And sometimes you come up with really good distractors, and sometimes you come up with goofy distractors, right? So for example, when I teach about the Yerkes-Dodson curve, which talks about, I think we might have mentioned this last week, it talks about like there's an optimal level of stressing out about something. If you stress out too much or too little, you're just not going to be that motivated. When I test about that, the multiple choice test that I have created, Yerkes-Dodson is the right answer. And then one of the distractors I have is Hames Frazier, who is not a psychologist. He's a guy I went to homecoming with in college, or not in college, in high school, right? But because his name looks like Björk Sodson, I will get people who answer that every year. So it's just sort of like a funny distractor for me. And conventionally, you'll have 3 or 4 distractors, and this is why typically when you take a multiple choice test, there are 4 to 5 answers. And so this is more help for y'all than anything else. Should I guess when I'm taking a multiple choice question test? It really depends on how the test is going to be scored. So if you're penalized for incorrect answers and you have no idea, it's better to skip that. If you are penalized for incorrect answers, and what I mean by this is, I think like the SAT, for example, if you get one wrong, not only do you not get the points for it, they take like a quarter of a point off your guessing. And you can narrow it down to like 1 or 2 possibilities, then guess. But if you're not penalized for incorrect answers, like on my tests, always guess. You have nothing to lose in those scenarios, right? I always say it's better to have a 25% chance than to have a 0% chance. So what I'm guessing, at least from my experience teaching this class, is that most of you, as you create your questionnaire for your group project, you will be creating something with a Likert scale. And a Likert scale is a statement is made and 5 or 6 or 7, depending, alternative answers are given. So something like strongly disagree, somewhat disagree, neutral, somewhat agree, and strongly agree. You can also flesh that one out, and I've seen this. So you'd have just a disagree between strongly disagree and somewhat disagree. And same thing, you'd have an agree between somewhat agree and completely agree. This is really good for measurements of any kind of attitudes, emotions, beliefs, because it gives information on the degree of agreement with that attitude or the degree to which you're experiencing that feeling. There's a fancy thing I won't make y'all do, but if you use a Likert scale, you can use a technique called factor analysis, and it will let you know if your questionnaire you came up with has more than one thing it's actually measuring. So for example, one of the measures I use in pretty much every study I ever give is called the Sociocultural Attitudes Towards Appearance questionnaire. And it includes items of like feeling pressure from specific people in your life to be thin. So like my family, my significant other, my friends, the media, but it also includes items about how you think about your body personally. And each of those, as you can imagine, kind of is a different subscale within the overall scale. You can also do something called a category format. And this would be similar to a Likert scale, but there'd be even more choices. This can be controversial because test takers can change the ratings based on the context. And so like, let's say I was using this as a rating scale on a student. And I have an average group of students in my class, and this student's getting an A. I might be like, stellar. Let's say I take the same student, different teacher, and they're in a class of all geniuses. That person might be like, average, right? So context matters. And you can avoid the problem with that by defining your endpoints clearly. Checklists are often used in personality assessment. And honestly, yeah.
Sorry, this is kind of going back. If you
Yeah,
said, I also don't really know how to word this, but like, our coach will like give us something, bring this 1 to 10, and he says we can't use 7s.
Oh, interesting.
Because like, you either have to pick 6 or 8. Like, do you ever see that in research where like 7 is like out? Like, he calls it like your safe number, and he said you can't pick it.
Oh, that's so
Like,
interesting.
do you think that like, I don't wanna say like ask me in words, like, do you think that would be more reliable than?
That's a good
numbers?
question. Yeah, and that's a debate within the field, honestly. So I've never within research seen like not allowing people to pick a number if it exists. right? But what will sometimes happen, let me go back a couple slides, is okay, let's say I have this Likert scale. And I like Likert scales like this, where there's an odd number, right? So you can have a true neutral. Other people who create questionnaires take out the neutral. So now you have to decide whether you disagree or agree with something, right? And so those are like two different philosophies of getting information, and sometimes there are times you want to push it. So for example, when we learn about the MMPI later in the semester, it's just a true false. This is true of me, this is false of me. But there are other questionnaires that do the same thing as the MMPI who thought that was too restricting. And so they'll have like not true of me, somewhat true of me, very true of me, right? And so yeah, it's like different philosophies of testing. It's so interesting that that's the way he's doing it. But yeah, it's kind of gets at the same thing as like, let's take out the one people usually answer, so they're forced to make a choice. That's such a comfort answer. I love that. It's true though, because like whenever I'm filling out a questionnaire and I'm not sure, I'm like 7, 8, somewhere in there, right? Good question. And then checklists, these adjective checklists, they're basically the same as true false. Because it's either a yes or a no, you check it or you don't, right? Yes, this is true, or no, that is not true. A Q sort. I don't expect anyone to do one of these, but it is sort of interesting to just talk about abstractly. So it's similar to the adjective checklist, but it offers more than 2 choices. Typically what you do is you would hand this to people, usually it's on like cards, but it could even be pieces of paper, and it would be like a word or a phrase that might describe you. And you might say, okay, that one's like somewhat true of me, that one's not true of me at all, but this one is somewhat true of me. Or you can have this as like a neurocognitive test, where you're like, put all the ones that are yellow in one pile, all the ones that are blue, all the ones that are red, and in fact, you say, type of Q sort, that's a measure of executive functioning, can you adapt and change, where you actually change the rules as people go, but you don't tell them you change the rules, you just start telling them the ones that were right before were wrong. And then they have to adapt. So lots of different ways you can do this, and you can make fine discriminations about the statements. And the items that are placed in the extreme categories give the most discriminating information. Again, that whole idea of taking out the neutral or taking out the seven. So once you have created items, and let's say you all, after this project, really like your assessment, you think it's great and want to do more with it, there's a whole bunch that you can do to look at the items you created and see how good they are. And in fact, in the past, I've had students who have taken this class end up using the questionnaire they created in this class on their Psych480 project, for example. So one of these is item difficulty, and this again is if you are testing people, seeing what they know, is there a right or wrong answer? And this is like the number of people who get an item correct. So if for item 11, 5 out of the 6 people got it right, then you would just sort of divide that, and it's 83% or 0.83 is your item difficulty. As we've acknowledged before, simply by guessing, test takers will get some right. And the optimum difficulty, in order to get an item, in order for an item discrimination among test takers, is between chance and 100%. So if there are 4 options, then my item discriminability should be between 25 and 100%. If there are only 2 options, my item discriminability should be between 50 and 100%. And haven't done this in years, but when I used to give tests to very big classes, so like this class, an upper level class, when where I taught in grad school, would probably have like 90 people in it. So I would give state Scantron exams because I couldn't grade the exams I give you and like sleep and eat, right? And like the Scantron would do that for you. They'd do that item analysis for you, which was kind of cool. Should the difficulty level be the same for all items? No, and when we talk about intelligence tests, we'll talk about how specifically they're not all the same on purpose. But even when I'm writing an exam, or for example, those of you who've taken adult psychopathology with me have seen these. I've actually written a set of interactive activities for a textbook that teaches about adult psychopathology. And over the summer, they wanted me to write quizzes to go with those. And they actually were like, you've got to have X number that fall into the like easy category, X number that fall into medium, X number that fall into hard. And they gave me ways to gauge that, which was really cool. So like item analysis on the fly while you're writing them. And difficulty levels of somewhere between 0.3 to 0.7. So essentially 30 to 70% of people will answer them correctly, have good discrimination for tests. Item difficulty levels tell you how many test takers get a particular item correct, but then item discriminability tells something about the people who answered an item correctly. So you can say, did the people who succeeded, who got a particular item right, do well on the test as a whole? Or let's say you're doing this with a questionnaire. Did the person who scored high on this particular item score high on the questionnaire as a whole? So did the success or failure on an item or the endorsement or not of an item on a test tell us something about the entire test or questionnaire? So how do you assess this item discriminability? There's a couple different ways. One is called the extreme group method, where you would divide the test takers into the top and bottom third and find the proportion of people in each group who got that particular answer right. This is called the discrimination index. And then there's the point by serial method, where the correlation between performance on the item and performance on the total test is examined. And the closer the correlation is to 1, the better the item works to discriminate high performers from low performers, or people who answer high on the questionnaire overall to people who don't. And as with this extreme group method, you would discard those with very low correlations. And this is something we do with questionnaires as well. We might start questionnaires when we first come up with them with way more items than we think we're actually going to end up on the final one. And then what you do is you correlate each one with the overall score on the test, and then it will tell you, just like we talked about last week with reliability, which items are most likely to relate to scoring high on the test overall. And when they have low item discriminability, you can chuck them, you can get rid of them. They're not adding to your reliability or to what the people have to do. You can graph the characteristics of a particular test item with what's called an item characteristic curve. And then this demonstrates whether the number of people who succeed on this particular item increases as a function of the total test score. And you can analyze various criterion reference items. These again would be things that are right or wrong. One of the things we really work on in psychology and in teaching in general is coming up with really specific learning objectives and trying to match our questions to those. You can, if you're doing this experimentally, look at experimental versus control folks. You teach something unrelated to the control group, and then you test both groups and see, did what I taught actually increase their knowledge? It's sad if it doesn't, right? But it could happen. And you can graph the difference with a frequency polygon that we looked at earlier in the class today. Item response theory is something that is done more modernly. I don't expect any of you to use this on your group project, but just want to kind of like fill you in on this is a thing that you can do. And it uses the power of technology to customize the items and the selection of the items to each test taker. It makes extensive use of item analysis. And so just like the GRE, that gets harder as you do well. It's like, if you endorse an item about depression, it's gonna give you more items about depression. If you don't endorse an item about depression, it's gonna give you fewer items about depression. And so your score is defined by the level of difficulties of items the test taker can answer correctly, or in the case of something like a personality inventory, the number of items they endorsed, but not by the total number of items. Alrighty, so again, that's just to kind of get the group juices flowing as you think about writing your questionnaires. And so what I have now, and you are free to work together in groups, partners, work on your own if you want, is I'll walk through what we did earlier in the class as a group. This is your next assignment, so you'll get a score for this. You can use your notes, calculators, all that good stuff. Thank you. There you go. Yeah. And I'm gonna be up here. If you have any questions, slide me down. But I'm gonna go grab my laptop. I can work on some stuff I need to work on in case nobody does see it. Even my guys. I'll find it, but I got it. I'll find that email. Okay, definitely feel free to work with each other, talk to each other.
If there's not enough space to go all the way down to 21, guys, do that. It's fine.
Yeah, whatever you need to make it work for your handwriting. And there's the second page, the back of it's blank, so if you need more space, you can always use that too.
No, I think it is my. When I was there, I really turned all around. Really. This year.
Oh, you know what? If it says 6.1, it means 4.1. I'm really sorry, y'all. They changed the chapters on me a couple years ago, and I just realized I didn't update that number. So it's 4.1. Is it 6.1? Okay, so maybe 6 is the right one, and it used to be 4. Okay.
Yeah.
I don't even like. Okay, so we're supposed to do it like highest number, the lowest number.
Yeah, you can do it either direction, honestly, but I think that's a usually with highest to lowest.
Really?
Let's
Wait a second.
I'm not gonna grade you wrong if you do it one way or the other. Let's put it that way.
Like.
There's nothing. You're not right, it's like the person number. Like, what else do you need?
The whole frequency.
Okay, yep, so not like that one.
Exactly. It might have you do that on the next page. No, I didn't have you do that. I decided I didn't care. So yeah, no, just do the whole frequency.
I don't think that's the same. That's
No, and I said, oh, they put the number, not the number.
So. One to five, 5 to 10, and 15 and 16 and 17.
So they take the order, but the scores in order.
It's five to one, it's not doing that.
Yeah.
I think we.
So number, there were people on the bottom.
So typically you do the scores along the bottom and then the number of people got each score up the side.
Did it by 5?
Yeah.
No, they're gonna have their own, but I don't know. Maybe we should look at. I would like to think so. Oh, you're serious. Three, 6, 9, 12. Well, and mine's not gonna be there at all. And then. It's going on to 21.
So is it 1 through 5?
When you want to divided by. Can we close together like on those?
If you want to, you can, you don't have to.
We could do it by 7.
You could just do all of them if that's easier for you.
1, 2, 3, 4, 5, 6, 7, 8. Yeah. I don't get prettier. I get weird. Weird. So when the roof were,
Yeah, a lot of trees.
so they could be touching.
Oh. Walk. Maybe it's 5.
You're right, yeah.
Okay, so it'll be the. Water. So. 1 column. Why is that?
No, fix that for me.
Peer review is done on this. I think in.
I'm looking forward.
How many this is it, I mean. Yeah.
The
Why?
Yeah. We're not even.
Oh.
Hey, so happy to get you on for me. If it's on Excel, and if you can print out rounds.
Yeah, so we're still doing one here. We're still doing we're doing before. Because then we're coming to blank trainings.
We said that.
21.
It just gives a little turn.
Little training. And then we got 21. Yes.
See that.
What? And the 21 is also the one? That's so sad. 11 is
Not the median, which one is right?
Look at this hard right now. Look at this.
I will find the median history.
It's not good. It's different. It goes like that. It's cute. It's cute. Okay. It's. You're counting.
No, the median is when you added all of it and divided. So.
No, before,
You like to.
Did you change it?
like if nobody got started, like.
So one, we added one. So we added 1 to 21. So 1 plus 2 plus 3.
That would make more sense.
Yeah, totally fine, right? Yeah, I want you to get the concept, I don't know if you're already looks.
Well, I'll take it over there.
Yeah.
I got it.
No, but they did a lot of it. Like the figure, it's the same figure, not this. The figure, hour long based off of.
I used to numbers in the book. Again, look, I just want you to learn the skill, that's so it's like this. We're looking pretty.
I got 7.9.
Yeah, you can round.
Oh.
Yeah.
Oh, I got it.
That's fine. Yeah, so like. Yeah. You don't have to.
Why did I not remember that?
Let's do it.
When you do the number.
Oh, they're all together.
So there's one.
If you're me, I just grab all of them.
You said one block. One, two, three, 4, 6, 7, 10. No, I.
Yes. All those numbers and divided for people.
I don't think you're right. I don't think you.
Okay, so this.
I just had to.
Oh, the graph. Yep.
And then everything goes to the.
Those numbers, let's go. Yep.
Okay.
Good question.
Maybe it's not.
I
We just did, we just did
think-
games on the day. That's right. I didn't invite.
Yeah, that's right.
Okay.
So that's the mean you found, then you, that's how you would do it.
Computer program.
Sophomore year.
And I just realized, Elijah, I need to send you the assignment. I think it's on Blackboard, but I can just give you the link.
So wait, what was the? I know.
Wait, we're right, All of the numbers, yes, yeah, what I wanted right now. Oh.
So Elijah, if you use that link, it should open a copy of it for you.
Okay.
This one, 8, not 4.